Okay, our next speaker is Mr. Faye Benson. He's a small farm supporter, small dairy educator with Cortland County Cornell Extension, Cooper Extension. He also oversees numerous of extension programs across the state, dealing with grazing, organic, dairy, and field crops.
Thanks, Joseph.
You're welcome.
So I'm here to talk about a project I've been doing for the last 3 years with SARE. Started looking at this. Let's see what's the best way to do this. You know, I've been grazing all my life on my dairy. I had a dairy farm for 20 years, and I grazing, and then I transitioned into organic, and then organic worked really well for us. We paid off our dairy in 20 years, or we paid off our dairy, paid off all the debt, and I decided to do something different. And I thought extension would be a good place to use my, what I knew. And so grazing has been a big part of what I do with Cornell, and I love to go visit farms and see what they're doing. And as you know, grazing has, can either be really good for the soil or it can be really bad for the soil. It covers all those principles that, soil health people really want to see. They want to see that permanent cover over the soil to protect it from the sun, from the rain droplets. They want to minimize soil disturbance so you don't lose the carbon out of the soil. They like to see plant diversity so you get different microbes in the soil. The continual plant root, pumping down those exudates from through photosynthesis into the soil all the time to feed those communities is important. And then the livestock integration has its own following. Some people believe in, some people say there's only 4, but us livestock producers know there's livestock is very important to soil health. So I was working on a farm up in northern New York, and I was doing a project where we were planting brassicas into fall pastures, because in the fall the cows, they kind of lose the taste for the grass a little bit. And so we thought by planting some brassicas in there that are cold growing, they also are very high in nutrients. So we thought we could, these were organic pastures, so we actually sprayed acetic acid along with the no-till drill. So it spot sprayed the grass to burn it back, and then the brassicas went in there, and they got up about 2-3 inches, really nice green, nice straight rows, and then the grass came back, and it just doesn't handle the competition. And but anyway, well, looking at that paddock that we were working in, the fence line, it was very obvious that there was a height difference under it, and I was just curious by that. And then I started looking at the sward that was growing underneath the fence was like great cool season grasses, just what you wanted to see in a pasture. And out in the pasture there was some woody type weeds, there was sedges growing, and there was just a real difference in it. And so it just made me really interested. But the other key thing about it, that when I pointed it out to the farmer who'd been there for 20-25 years, he'd never even noticed it. And what I came to realize that under compaction is that it happens very slowly over time. That if you're not really observing it or have any way to monitor it, it can becomes a problem, and it really is a disturbance to the soil. You're changing the properties of the soil. So I wrote this SARE grant. We said we'd convene educators from the Northeast. We did 2 trainings. We had people from different Northeast states, and then we would provide these educators with funds and equipment to do trainings in their area. And this included, we have a New York soil health trailer that's been very popular in our area, and so to put on those things. And then thirdly, I wanted to try a research component of it, which is the pasture compaction ratio. Because as I said, if you're not monitoring that compaction, it can sneak up on you without you even knowing it. So, but the tools we have, the penetrometer, really isn't a good tool for monitoring from year to year, because it depends on how dry your soil is, how much resistance there is. So I will talk about that, and that's really kind of the hope. I have enough time to cover all that, because it's a 3-year project, and I really had trouble cutting this down to what they needed. So anyway, the educators, they received a half day. I worked with a retired professor from University of Pennsylvania and a Cornell soil scientist that works with the Soil Health Laboratory. And they, along with myself, we did a half day in the classroom. Then we went out to a local pasture, and we had a soil pit, and just to show the educators there, what to look for, how to identify problems in your soil. And then we went on to start, having events. We got all the way up to Maine, doing events, and geez, I don't have my pointer, but this was an interesting pan for me. I mean, that was the great thing about, as a farmer, I'm always looking on top of the soil, and I don't get down there with a shovel that much. And this was a fun project because I did a lot more digging. So this was from the fence line. And if you looked up close to it, you'd see really nice aggregate shapes, nice round shapes, and you say, oh, that's great. But this was in the middle of a drought up there, and the grass had already gone dormant underneath the fence line, and out in the pastures, it was still green and functioning. And what it told me about compaction was that you really need that combination of big pores, small pores, intermediate pores. The small pores hold that water, and they don't lose it in droughts. They hold onto it and keep the plants going during droughts. The big pores are really good for rainfalls, getting the water to go through it. But if you have nothing but that, you're going to lose. You're not going to be able to hold the water for the drought. We did pasture events around the state. We did them at conferences. I managed the soil health trailer in New York, and I always kept 2 soil pans on our rainfall simulator. One had a really good rotational pasture on the left, and the picture on the left, but the left-hand pan is the rotational pasture. And then the compacted pasture I cut from a neighbor who has continuous grazing, has about 60 head on 50 acres. They get most of their feed off from bales. The grass looks like artificial turf, like on a football field is what it looks like. And that's what it feels like too. It's very hard and compacted. And the rainfall simulator did a great job of showing, in that picture you can see in the back jar under the rotational, that's where all the water is that came through. And the front jar, which would catch any runoff, has nothing in it. The compacted pasture is about half and half is what it would usually show up. About half the water would go through the soil and half the water would run off. But it was a real good educational tool. So looking at, I did some reading on, how much compaction do cows have. It was interesting to see that one of the studies showed that cows actually have more compaction per square inch than tractors, most tractors. I found this really hard to believe, but I found it often enough that it proved it. But the real problem, the difference in it, is that you can see from the drawing there that even though the weight is spread out more on a tractor, because if it is heavier, it goes deeper. And that's where a lot of the problem is for those having tractor compaction versus cow compaction. The compaction cows give is not that deep, depending on your type of soil, the type of organic matter you have, how deep does it go. Let's see if my videos run any better. When I sold my milk cows, I did custom grazing, and that cow that was in the cartoon there was standing on all 4 feet. These cows are running, so I get 60 to 70 heifers that had never been outside before. They never seen grass, they'd never seen trees move. They're wild when they get there, and you have to have, good fence doesn't make it because they don't see it. What you need is the flutter tape, something they can see 10 yards before they get to it and stop. but they run all day long, and even during the summer. They just love, all of a sudden start running to the other end of the pasture. But they can cause, that kind of weight can cause a lot of compaction. So according to the rangeland soil quality, compaction is a problem when increased soil density and decreased pore space limit water infiltration, percolation, and storage, plant growth, and nutrient cycling. So just to be totally honest about you, I really thought, compaction is really an evil thing. We got to figure out how to, control this. You can't get away from it. We got to put our animals out every day. There's going to be wet soil, and that's the worst time to have animals on it. But how to control it is really, I thought it was a much more evil of a problem than I've turned out to be from doing this study. This is a good rendition of what we're talking about with pore spaces. The bigger pore spaces allow roots and air and water to get through the soil. The intermediates, hold on to air and water, and the small pores are really important too. I did a lot of demonstrations. We showed the trainees, educators, how to do these demonstrations that would help, back up the story, because you can tell farmers over and over something, but when you show them a demonstration, it makes all the difference for them. So, the slake test is here on my right. Yes, your left. I got to remember that. And that's one of the first demonstrations I always do. I take two soils that are taken 10 feet apart. One has had the soil research lab at Cornell, where they're planting the small grain crops. They till it every year, and then the sod growing right next to it. So I have that soil, and I put, and it's about 2% organic matter that's in this nearest jar, and then 5% in the other jar. And it's just a remarkable difference in how they break apart. When you put them in the water. How many people here have seen the slake test? Yes, yeah. So I don't need to tell you that. The double ring infiltrometer we use, you do that. I did it, in the pasture, and then we do it under the fence line, pushing the infiltrometer into the water, into the soil, pouring a gallon of water in both rings, and then we pour a set amount of water in the middle ring, and you can see the difference between under the fence line. And those demonstrations are really good to tell your story. In good soil that's undisturbed, you want to see about half the space given to air and water. That's hard to imagine, but 45% is the sand, silt, and clay. And then 5% you hope is organic matter. But when you get severely compacted soil, that you lose a lot of the air space, cuts down on the water, the pore spaces, and you have mainly just sand, silt, and clay. It's all about losing that space. And this is some of the new knowledge about soils and plants and the interactions. The rhizosphere, which is the microscopic area between the roots and the soil, is just highly important in the transmission of the exudates that are coming from the plant, that's putting down carbohydrates, leaking it out purposely to feed the biology in the soil. And they do this by putting it out into this rhizosphere. And so the biology is coming to the rhizosphere to feed on that energy. And then they trade back what they can give to the plant, because bacteria are breaking down organic matter, changing it into nutrients that the plant can use. The mycorrhizae is bringing in nutrients and water to the roots as well. So that interaction, that symbiotic relationship between the plant and the microbes really happens in this space. And so without cutting down that space through compaction, you're really impacting this exchange. So when we looked at the soil in the soil pit, if you're looking for that compaction zone, how deep, if it's really severe, you'll see that the plants, the roots actually start growing horizontal at that point. Looking at the soil more, you get a blocky nature to the soil, where it comes out of the soil in chunks like it's showing there. And then also the picture of the Larry's holding up, he found this layer in the soil, and it just, you could pick it right off. It was like it was two different soils that weren't even joined together. And it was about 6 inches below the soil, and that's the platy nature. And that's really a good indication that you have compaction in your soil. And these are things that farmers can do if they just take a shovel with them occasionally. I know how busy they are, but it's a good fun thing to do on a pasture walk, is just take a scoop of soil and get down there and take a look what's happening in the soil. I talked about the penetrometer and how that's really a basic tool for measuring compaction. It just measures, as you push down, it comes back with how much pounds per square inch that you're putting on the soil. And it's indication of what the roots are feeling when they're trying to go through the soil. And what they say is that roots can really only penetrate 300 pounds per square inch. And anything close to that, they slow down. But the problem with it is that if you take a reading today and it's a hot sunny day, tomorrow you're going to get a different reading, because as it dries out, there's going to be more resistance. When it rains, there's less resistance. So that was the, I forgot about this. So this is back up in northern New York, and I took some soil samples underneath the fence line and out in the pasture. And this is just looking at the pH, phosphorus, potassium, and minor elements. pH of 6.5 versus, and that's under the fence. Out in the pasture is 6.3. There are some differences there, but not really big differences. It's only when we have the Cornell Soil Health Assessment that we're able to see the differences. And the soil health assessment uses chemical, biological, and physical. And it gives farmers a reading of their soils with all these different, each has a different test to give them a reading. And then the ratings, you can see, this is an older version of it. They've changed it now, but they use colors to, green is obviously good, yellow is caution, and red is danger. And you can see that the one on your far side over there is the compaction, was the real difference in that soil. So that was, the beginning of when I was writing the grant, I used that information. In preventing compactions, much easier than fixing it. Having good laneways, using those laneways so that when there are times of compaction, that they're, keep track of time here, that it's centralized so that they have, they do their compaction where it's centralized, and then get to the paddocks that they need to get to. In organic matter, it's been shown that those aggregate structures, and we showed in the slake test how important they are for water to rush through it without breaking them apart. That's also a benefit for preventing compaction, because the aggregate structure, if it's strong, can withstand the weight of the animals and spread it out more than organic soil that has low organic matter and low aggregate stability. And so it's important to graze plants with more mature roots. The roots go deeper, there's more sugar provided to the soil. These are all just good grazing advice. Monitor and assure healthy plants. Short residences is really important. When I had the soil health trailer with the two pans of soil, one with the rotational grazing, grass up to here, the compacted grazing, with grass right down here. I just showed, with my fingers as a cow, how far she had to walk around to get a mouthful of grass on that grass, and how much walking, versus the other rotational grazing where they can walk in, they fill up, and they're moved off from the field rather quickly. The residencies and paddocks is another important one. And then I found that there was a difference in soils. At first I thought clay probably was a big problem. I always think of clay as a compaction thing. But I found that, in reading some of the literature, it's more sand with silt. And sandy silt is probably one of the hardest ones in our area that you can compact quickly. And it turns out, I forgot to show that on the soil health assessment, but that one in northern New York, his was a sandy silt loam. And that's why there was a 6 to 8 inch difference in that soil, just where it had been compacted for 25 years. You know, switching to hay production, that's what is one of the things I did for this study that I'm going to talk about, and draining perennial wet spots, you know, to keep moisture under control. This was an interesting study I found, and it's talking about like when we first started grazing in the Northeast, you know, New Zealand was a heavy model for us. You know, bring them in at 10 inches and take them out at 3 inches. And so that's how we did it. But we found over time that taller grass grazing seems to work a little bit better in our area. And what this study was showing was that that quick grazing with not immature plants, but less mature plants, there's less lignin involved with it, is the carbon source. So you're grazing plants that lignin doesn't come through into the manure, and you can actually lose carbon in your soil through that grazing style. So by grazing, you know, longer, more mature plants, a little more lignin in there, you're leaving a little more lignin. That's the way to build more carbon into your soil. Yeah, curing it, obviously, you know, bringing bale feeding in if you want to increase your organic matter. There's different ways to do that. The one in there that's numbered 1 is a great way if you have the time to do it. It spreads it out. It also, the cows are able to walk on that mat to help relieve, you know, or prevent any more compaction. You know, growing brassicas, they did grow in that study that I did, but they grew in areas where it was denuded of any kind of living grass. I mean, if there was no grass around, the brassicas actually did quite well. Yeah, and you know, you get these sacrifice areas, everybody's going to have them. This one here, you can see the first thing we suggested is that they move the fence beyond that waterway so that there was a good grass cover over that. But then you know, if you're brassicas and small grains is a good thing to get in there as soon as you can in the spring, just to get something growing, and then the native grasses will come back in, but just to give some cover on there. So this is the research component of it, the pasture compaction ratio. And let's see. So my theory was, you know, I said how hard it is with a penetrometer. It changes every day depending on the moisture of your soil. So I was thinking, well, under that fence line, we have a very unique area. There's no cows, no tractors can get under that fence line. So I'll take a penetration reading there, and then 10 feet or so out into the pasture, I'll take another reading, and then I'm going to use that ratio. Because as the one, you know, one gets more moist, less resistance, the other one should get more moist, less resistance. So maybe that ratio is going to remain constant, and that would be something that we could use to monitor compaction in these pastures. So we looked for areas that had a fence line that had been in place for at least 5 years and had permanent pastures for at least 5 years. And then we would take at least 5 readings underneath the fence line, 5 readings out in the pasture, and calculate the pasture compaction ratio. Excuse me. So again, going back to the Zufall farm up in northern New York, we had those readings from the soil health assessment, and the surface was 200 pounds per square inch on that day, and the same day the pasture was 300 pounds per square inch. So the pasture compaction ratio divided the fence line by the pasture compaction, and so we came up with a 0.66 pasture compaction ratio for that farm. I just threw these in here because 2020, we had a shutdown. We couldn't do any events, obviously. I worked with Sayre to say, okay, I can't do these events that I was going to do. I'm going to add some more farms, more paddocks into the pasture compaction, the research part of it. So just a quick explanation of what we're looking at. Pounds per square inch is the penetrometer reading. The blue is the pasture, so they had higher, pasture had more compaction. These are dates. The fence line, on the same day we took them. And then the pasture compaction ratio is the gray line. And, you know, it wasn't a perfect comparison, or the ratio, but it did, you know, if I saw a perfectly straight line on that PCR, I would have been very happy with it. But there's still some abnormalities with it that I haven't been able to explain. But it's pretty good. You know, as you can see, as the summer wore on, both compactions went up almost equally and came down equally in the fall. Of course, this was 2020. We had a very dry year. I couldn't take readings from July through September because it was over 500 pounds per square inch. Just another one, just to show you that the bottom line there, the pasture compaction ratio really did kind of keep a even comparison. And okay, so this is the part on the farm I was explaining that had like the AstroTurf grazing. I decided to put in an enclosure on this farm, and you know, it's just 10 by 10, and you know, the cows were greedily looking inside, and they never got through it. All 3 years that was there, 2.5 years, they never bothered it. I was surprised. And so I simulated hay growth within the enclosure, and then I started doing the results. So this is the first year before the enclosure went in. You know, again, you know, fence line, pasture, and that's the ratio. And then this is the year 2020 of the, let me see how much time. But what I want to, this is the one, and I didn't complete this graph until just a few weeks ago, and it really told me the story of what I wanted to know all along. So what we're looking at here is these blue lines came from one of the graphs I showed you already, 2019's pasture compaction ratio. These are all pasture compaction ratio, PCRs. So the blue line, 2019, stayed pretty much straight all the way. This is the pasture PCR. So there was some waviness in that. I'm not sure why that was. But then the gray one, it was the enclosure. And so I put the enclosure in November of 2019. By April, they're all starting at the same spot. May, slight deviation. But then May and June, it really started deviating and stayed deviated, which is saying that the closer to 1 I am, the less compaction, because that's equal to the fence line. And so this is how far they are from the fence line, and the enclosure improved the compaction considerably and rather quickly. I mean, it just took, it took from November. I don't know what happens in the fall. I would like to know more about frost heaving and all that, but we wasn't able to capture that. But it did improve. As soon as May came around, whether it's the growth of the roots or whatever, putting in the exudates from the plants, feeding the biology, it really improved the. So this slide really told me that one, my pasture compaction ratio is a really good tool for monitoring, because if my fence line is staying the same, and then I can measure it every year to see how, if it's close together, or if I'm getting some deviation or some width in it. So it told me that my PCR does work as a monitoring tool, and it also shows that pasture compaction really corrects itself really quickly in pastures. That's what I'm really happy to see. You can have one of those sacrifice areas, really beat it up terrible, but if you give it some time, within a matter of a few months, it'll come back again. The real damage is done is when they don't know what happens. It stays compacted year after year, and that changes the makeup of the sward. You get the sedge grasses that the cows won't eat. You get the bluegrass that only grows very on the surface of the soil, but it's not very, very productive. So it's the how long you leave it compacted is the real damage. Oh, I won't even get into this. Electromagnetic imaging, we just tried it just to see what we could see. Got a very blurry glob. One thing we noticed was that somebody must have lost a fence handle out in the field or something metal. But anyway, another one is takeaways. PCR will help grazers monitor their compaction. Time cures compaction quite easily. As I said, real damage is prolonged compaction, changing the sward, and more work needed for soil texture and compaction. And there's more about compaction that haste, when the enclosure really didn't come back robust. I mean, it still never got grass more than 10, 12 inches for each of the cuttings. Excuse me. But, as what I learned in farming and what I've learned in doing extension work, there's always more work that needs to be done. So that's the end of my talk.
Okay, any questions?
The last chart, was it about those heifers, the dairy heifers, or was it mature cows that you
On this graph here, you mean?
Yes.
Yeah, that was, there were some beef cows that I had in another picture, not the heifers, no. Go ahead, Joseph, I'll let you call on.
So what length of time was it? Was it like 90 days that you saw the response of resting it or letting it recover?
I think that's pretty good, and because it backed up something I saw with the soil health trailer. I had those two pans, the rotational and the compacted pasture. After I started going around week after week, all of a sudden I realized my compacted pasture was working just as good as the other one. And so then I had to get up and put a board on it and stand on it a little bit to get it back down there.
Oh, man with the hat there.
Question. So, do you have any data about the effect that insects might have on helping alleviate the soil compaction? What I mean by that is, we talked about earlier about pores. It got me thinking about dung beetles and how some of the termites make a big, wide hole. And I understand it's very complicated, but I was just curious. Do you have this cornality?
I haven't done any reading on it. I mean, that's the best thing about doing all this research is done what's already been done. And I didn't see any information along that, but it makes sense what you're asking.
Right here.
Have you heard of any relationship between soil compaction and bitterweed?
Bitterweed.
Bitterweeds are.
Oh, okay.
Weeds, actually.
Okay.
Definitely a relationship.
Oh, is that right? Okay.
Because our pasture was, before we bought the farm, it was like continuously grazed for probably 40 or 50 years. And then we bought it and started doing rotational grazing, and my husband's, we're not using any chemicals, so we're trying to be as organic as we can. So
Yep.
we've been doing rotational and cut them, with the.
And do you feel the rotational is correcting it?
Maybe some.
Yeah.
It takes a lot of effort. One article we read said it takes 10 years to get, at least 10 years to get rid of bitter sneeze weed. And then it's really frustrating, especially since my husband's
Yeah.
allergic to it, so when he goes out, it gets all itchy and red and
Oh.
knows it,
Yeah, I mean, I think that is the thing about compaction. The longer it happens, the longer it takes to get rid of. It goes deeper and deeper and deeper. Yeah.
Did I hear you right, that you said that the pasture that was showing the compaction versus the fence line actually did better in the drought than the?
Yeah, I mean, in that case, and I'm not saying that's across all cases, I'm just saying, that's another example of it depends. But I think what the soil scientists that I've taken trainings from is, the importance of having a variety of pore sizes in your soil, not having just one or another.
On that question, would the pore sizes on a compacted be more like a clay that would hold water tighter, whereas the fence line was looser, had more opening, and the water would go through and wouldn't come back? Would that be a possibility?
In that one case that we saw, I mean, I did core samples in every pasture walk I did. That was the only one I saw that dramatic and in the middle of a drought. I mean, so I can't say that, it's not going to happen there every time, I wouldn't imagine.
Okay, but I just think that clay particles are tighter together, it allows the water to be held
Yeah,
together longer, whereas, a sand with an open, they'll go through. So
Right.
if you got a same type of soil, but you've got larger, air spaces, and you have a drought, you're not getting the replenishment of water in that open soil section, whereas with the tighter compacted soil, it's able to hold the moisture longer than having, and you're not replenishing it, but it's holding it
yes,
longer.
yes.
That may be, and it may be available in the plant root.
And it goes back to that soil texture thing is important to know about your soil. You know.
You get a lot of runoff from the compaction.
Yes, yeah.
Okay, this is in this segment. And
Thank
give
you.
Mr. Fry a hand.